Oops. All right, guys. So what I'm going to do is I'm going to make you all presenters. So Dustin, Dominic, you guys are now presenters. So you can type in those notes sheets. And let me just get back to the main screen. Okay, so it looks like you guys are all doing well. Dustin, how are you doing? And you can see there's the chat up in the top kind of left area. It's a little bit different than last time. You're tired. I know, me too. I had to get up early today. All right, you guys, well, why don't you work on that? See if you can simplify those and type. Dustin, if you want to take notes 9, and Dominique, if you want to take notes 10, and see what you guys get. Just try to simplify those problems. And Donnell, it looks like, are you finished with the first? Okay. Are you starting the second, or are you working on the first one still? Looks good. Very good, very good. Okay. So just to make sure, I just want to troubleshoot. Dustin, if you can click on that text tool on the Notes 9 sheet and click in the box and type 1 parenthesis, I just want to make sure, just like it looks like Dominique, you did that in Notes 10, so you're good to go. So Dustin, I just want to make sure you can type. Oh, very good. Okay, good. All right, we'll see if you can simplify that. Just want to review a little bit. It seemed like we had some trouble with that last time. Okay, so Donnell, good job. So Dustin and me and Dominic, you guys, it might help if you just start typing the problem out. And if you guys have access to microphones, if you want to set up your microphone, you're more than welcome to. Donnell, how's your microphone sounding? Good, good. All right, you look like you're doing pretty good. Okay, so Dustin, are you thinking? Yep, okay. Dominic, how about you? Hey Dominic, if you are there, if you could chat me a message, just say yes, I'm thinking, or I'm not sure. Good, you're typing. Yeah, okay, good. All right, it looks like Dustin, you're starting off. Excellent. And this is really good, you guys, because I just noticed this week when we were simplifying expressions, there were just some misconceptions and some things you were forgetting, and I just wanted to go through that. Okay, so Dominique, your writer is struggling a little bit right now, huh? Okay. All right. Well, just do the best you can, and like I said, we'll go through it together in a minute. Just give you guys a chance to get as much as you can. And really think about your order of operations. Think about your PEMDAS. Remember your parentheses, your exponents, multiplication, division, addition, subtraction. The other thing that I saw last week from you guys, oh, how do you take a note? Okay, so if you want a note, just click on Notes 11, click on the T, and then you can start typing. It'll look a little strange because when you start typing after you click on that T, it won't, your cursor won't show up on the screen. Oh, actually, you know what? You need to be made a presenter, Wendy, if you want to. I'll make you a presenter. Give me a second here. Right now you are merely a participant, so let's make you a presenter. Okay. So, Wendy, yeah, I hope you do rock this problem. You better. It looks like Lita, you just joined. Where are ya? There you go. And Lita, I'm going to make you a presenter as well so that you can take a note. So welcome. Lita, how are you? And Lita, if you're in and you can see the chat, you can type in that little box. You can just say hi if you want. Ah, very good. Hopefully am I saying your name correctly, by the way? Is it Lita? Ah, very good. Just wanted to make sure. So yeah, Lita, if you want to take notes 12, you can work on these two problems. We're just trying to review how to simplify the expressions. And to get into notes 12, if you just click on the T, then you can start typing in the box. The T stands for text. And I'm just looking at some of you guys' work. So the other thing I was going to tell you guys is that when you get it all the way down to addition and subtraction, you just want to make sure to add and subtract from left to right. Okay, just like you're reading a book. Go from left to right. Some of you guys were, but that doesn't mean you have to fail now, does it, Wendy? No. You could still do very well. None of you guys are going to fail math in high school. Everyone's going to do great, especially since you attended the webinars. All right, Lita, looks good. Looks good so far. All right, so now let's see. Let's look at what you're doing. So you're definitely on the right track. I like how you're doing it step by step. The one thing I would say, Donnell, is just be careful when you're distributing, like the 4. You're doing a good job. You did the multiplication, but remember that the 4 still has to multiply by the 5. Okay, and then your 2 needs to multiply by the y as well as by the 6. Okay, so just be really careful. And then I think, Dustin, I think you were in notes 9. Let me see how you're doing. Okay, so same thing with you, Dustin. You've got the 4 times the x, but then you got to do the 4 times the 5. Okay, and then you got to do the 2 times the y. It looks like you're trying to do some stuff in the parentheses. Now, if you guys think about these problems, the stuff inside the parentheses, the x and the 5, those can't be combined, right? Those aren't like terms. All right, so Dominique, you're going to work on writer for a little bit. Okay, so Dominique, you're back. That's okay. Hopefully you still have a good connection. And so Dominique, you're on the right track, actually. That's fine. Yeah, if he comes down, come on back in. I'll notice you. But it looks like you're doing okay so far. But just make sure that if you do get out, Dominique, that you watch this after the fact, and then you'll end up having a small assignment associated with it. But yeah, definitely if you need to leave and come back, it's not a problem. And Wendy, looking pretty good. Looking pretty good so far. Lita, all right, you're on the right track. Except I'm not sure you need those parentheses actually, Lita, but you're on the right track. You're doing great. Those parentheses make it look like multiplication, but you did distribute correctly because you got the negative 4x and you got the 20. All right, you guys, you guys are doing a really good Yes, you rock. You guys, Miss Doran, she's your principal, and she rocked that problem. Just want you all to know. And she said she even failed high school math, so you can still be very successful. All right, guys, so what I'm going to do, it looks like you guys are mostly done with one, but let's just go through it number one together and get started. If you're at home and you want to write these problems down, or obviously you can watch this video because it's being recorded, you can try this again at home just for a little bit more practice, and you can compare it to the answers that we get. But let's go through, let's look at this. So again, if you guys think of PEMDAS, so I'm going to write PEMDAS up here so we remember. That is your order of operations. Okay, and a lot of you know that, and a lot of you told me that. But just because there's a letter there doesn't mean that we always have to do that letter. Sometimes we skip it if we can't do anything. So if we look at the first one, the P for parentheses, if you look at what's in the parentheses, you have an x plus 5. So why don't you guys, somebody type up there, can we combine the x and the 5? Let's see. Lita's going to answer. Great. Awesome. Okay, good. And Donnell answered too. Way to go. No, you can't combine those. Very good, guys. Those are not like terms, so we can't put those together. So we can't do anything with those parentheses. Same with the second set of parentheses, the y minus 6. Can't do anything with those. So then we move to the next, exponents. Well, we have no exponents, so let's go to multiplication. We have two different multiplications. We have the -4, which will multiply by this parentheses, and then we have the 2, which will multiply by the second parentheses. Now when you guys do this, if you recall, you've got to do the -4 times the x, but then you also have to do the -4 times the 5. Okay, and the same with the 2 and the y and the 6. So if we do that, -4 times x, everybody should have -4x. Okay, so it looks like a lot of you guys did know to do that, so that's excellent. And then where are you getting tripped up? So we have this plus in here. Well, we still keep the plus, right? So we can do plus, but now look at what we're multiplying. We're multiplying the -4 times the 5. So what we have is -20. So we would write -20. And I know some of you guys might take a shortcut and just write it as -4x minus 20, and that's fine too. It's the same thing as -4x plus a -20. All right, how are you guys doing? Okay. All right, let's keep going. So now we'll go on to the next set of parentheses. So we have a 2 times y, and that gets us 2y. And again, it doesn't seem like you guys have any trouble doing the first distribution. It's the second one where you kind of struggle. So now you have a 2 times a -6, right? That's -6. So again, it's easier if you just write that minus in there, and then you multiply the 2 and the 6 and get 12. So earlier in the last set of parentheses, we just dropped that plus sign down in, and then we did -4 times 5 to get our -20. Okay, and then I'm going to write the rest of the problem out. And Donnell, I noticed you were doing a pretty good job writing out each time. And that really helps you not forget any steps. It looks like a lot of you guys, Dustin, you were doing that too. Writing out each time the full thing. So Lita, you're still working on that. That's good. Okay, now you guys, all we have to do is combine like terms. And here's where I say, hey, let's go from left to right. So we've got -4x right here in the front. And let's just... Dustin's on 10. Oh, Dustin, you're on 10. That was Dominic. That was on 9. Okay, I see what you're saying. Okay, sorry. But yeah, so let's see, Dustin. So yeah, it looks good. Looks good. And Lena's on 12. Okay. All right, you guys. So anyway, combining like terms. So we've got this x term, and we've got another x term here. So we combine those first. So we have a -4x minus 3x. That gives us -7x. Okay. All right. And then let's look at this. So we have, and I'll change my color, maybe. Find my cursor. We've got a negative 20. And the only other term that looks like that is a negative 12, right? We can't combine the y's with the 20s and the 12s. Those are not like terms. So we've got negative 20 minus 12 gives us negative 32. Okay. And then finally now we can move on to our y's. Try a little purple. And we've got a 2y and a y. So 2y plus y is 3y. Okay. All right, you guys, any questions? Does anybody have any questions on simplifying? All right, Lita, did you just type no? Donnell, how are you? Doing okay? Okay, good. And Dustin, how are you doing? Peachy, okay. And Lita, it looks like you're still going at it, but looks like you're doing all right. All right, you guys. So if there's no questions, let's just go through the last one real quickly, and then we'll start our new material. So again, and actually, Donnell, can you hear me? Hey, you might want to put your either put your headphones back on or mute your microphone just because I can hear myself, like there's some feedback going on or something. All right, sounds better. Thanks, Donnell. Okay, so next one, you guys, same thing. We're going to distribute. So 2 times 10a is going to give us 20a. So we would write 20a. And then remember that that 2 has to multiply by the b. So 2 times b is going to give us 2b. 2b or not 2b. Okay, a little tricky over here. There's nothing in front of the parentheses. Although there really is something, it's just understood to be a 1. So if you don't see anything there, assume that it's a 1. So what we really have is negative 1 times 3, which gets us negative 3. Negative 1 times negative 5a. And remember, guys, you got to remember to distribute that. Well, negative times a negative is a positive. So positive 5a. And then I'll just go ahead and write the rest of everything out so I don't forget it. And now it's as simple as adding and subtracting. So we're going to add our a's together. We have 20a plus 5a is 25a plus 4a is 29a. Okay. Then let's go to our b's. We've got 2b minus 6b. Well, 2 minus 6 is a negative 4, so that would be negative 4b. And then finally, we just have this lone little 3 out here, this negative 3. We don't want to forget about that. All right, good. So let's move on, unless there's any questions. If there's any questions, go ahead and type me a chat. That must be your math teacher, Mr. Rossi, I'm sure. Yep, he would be proud of you. Very nice job. All right, good job, all of you guys. Good job for trying. And like I said, just maybe go home and work on this a little bit. Okay, so go home and try it again on your own. All right, so moving on. So at the end of today, guys, you will be able to create some expressions from patterns. And you'll notice that in this week's lessons, you've got a lot of patterns. You've got patterns in tables. You've still got some patterns in shapes. And you're going to solve single variable equations. So now we're moving to solving. Last week we did combining and simplifying expressions, and this week we will be solving actual equations. All right. And where's my mouse here? So let's look at some patterns. And you guys have seen these patterns last week, and you tried to come up with an expression to model the pattern. And we're going to formalize that this week by creating an expression from a table, actually. We're going to put the information we have into a table, and then we can build an expression from the table. And that'll make things a little bit easier. So here we have a t-table. On the left, we call this the figure number, so whatever figure we're on. And on the right, we have the number of blocks in that figure. Okay, and just to kind of get you guys used to it, a lot of times what we say is that the left side is our x value and the right side is our y value. Okay, and we're going to start working with that as we move forward. But for now, think of it as figure. So we have figure number 1. Okay, all we have to do is count how many blocks are in figure number 1. Looks to me like we have 5. Okay, pretty easy so far. Very good, Donnell, very good. So figure number 2, how many blocks do we have in figure number 2? Awesome, we do, we have 9. And how about the last one, figure number 3? Very good, very good. Okay, all you guys. So what I want you to do is to think of some kind of a pattern that you might see and type it in the chat window, who sees a pattern, whatever, look at it for a couple seconds or maybe longer. See if you can see a pattern. Okay, Lita's got an idea. You can see that they add 4 every time. Good, exactly right. So did you guys all see that too? Donnell, how about you? I hear you laughing over there. Do you see that they go up by 4 every time? Okay. So you are right. So good job, guys. So each time, if you notice, we increase, our pattern grows by 4 every time. And notice that's a constant growth. That's a constant rate of change. And you'll see we're going to start graphing these actually later this week. And when you graph a constant rate of change, what do you think your graph looks like? Do you think that we have a curved line, a straight line? Hopefully the echo's gone now, Lita, because I think Donnell had his mic open there for a minute. A slope, okay. That is our slope, very good. So Lita's already jumped ahead. That change, that constant growth, that is our slope. Okay, so our slope is 4, very good. So is this going to be a straight line, guys? So Dustin, are you still there? Lita's typing. Dustin, if you are still there, what do you think? Is this going to be a straight line? Okay, good. And both Lita and Dustin. So Lita, you think that yes, it's going to be a straight line and diagonal. Okay, so at an angle. And we're waiting on Dustin real quick. See what he says. Yep, linear equation, isn't it? Yep, you're exactly right, Dustin. Way to go. It is going to be a linear equation. Very good. So since you guys are so advanced, let's actually build an equation or build an expression. So I think Lita said that 4 was our slope. So when we write a linear equation, oh, you said that. I'm sorry, Donnell, I'm sorry. Oh, it looks like, and Lita typed it too, maybe. Okay, good. So we have a slope of 4. So that is our constant rate of change. Okay, and you guys remember the ice cream problem from last week? It cost 50 cents per every ice cream cone that we sold. And so X represented the ice cream number of ice cream cones. So in this case, X represents what figure we're on. And if we multiply 4, which is our slope, which was our rate of change, by the figure, we get 4. But look at this first one. We should be getting 5. So if we multiply 4 times 1, we just get 4. What do we need to do to get 5? Am I talking too loud? I'm used to talking loud. I'm used to being in a classroom. Ah, Lita, good job. Add 1. Good job. Could be. I could be talking loud too. I tend to talk loud. So Lita said to add 1. So let's try that with the 2. So 4 times 2 is 8. If we add 1, do we get 9? Four times 2 is 8. Okay. So 4 times 2 is 8, plus 1, we do get 9, right? Okay, guys. Let's try it with the 3 just to double check. So 4 times 3 is 12. If we add 1, do we get 13? Yes. So we can say then that, no? You sure about that? Yes, good. That's okay. You guys are all right. It's yes. So if we take 4 times whatever figure or x value, remember we said that also represented x, and we add 1, we actually get our y column, right? Or our number of blocks. So look at what you guys have done. You have built an expression, you have built a rule for this pattern using the table to help you, which is a lot easier than just looking at the figure and trying to build a rule. Ah, I'm glad you understand, Lita. Very good. So actually, now that you guys are good at that, let's try another one. So why don't you take your notes, you see your little notes, and I don't know if you want to just kind of add on to the bottom of those, that's fine, and they can scroll down once you get down a ways. See if you can, and go ahead and use the table if you want. I'll go ahead and build the table and see if you can come up with an expression to represent the pattern. So come up with a rule, just like we did, and then once you have the rule, then see if you can find what the 30th frame would be, how many blocks would be in that 30th frame. Okay, so you guys try this one on your own. And I'll build the, like I said, I'll build the table for you. And you, is it going up by 2? That's an awesome first start. So think about what you would need to do to get this number of blocks if you know it goes up by 2 every time. That was really fast. Oops. Okay, so Donnell, 35 is your answer for question C, right? So see if you can actually come up with the rule. So think about what it is, guys, and type something in your notes pods. Ah, okay, so Lita, you did it in the chat. That's totally fine. So Lita, you got 2x plus 2. And Dustin, you're typing 2. And like I said, you guys are more than welcome to type it in your pods if you want as well. And so Dustin, you said plus 2, right? It's not really sure exactly what you're saying on that one. Oh, you got 1x plus 2. Okay. And so, Donnell, what do you think the equation is? You identified that it was going up by 2. Do you have an idea of what you think the equation is? And again, you guys, totally fine if you want to type in the chat, but you're more than welcome to type in your notes too. Okay, so you think same as Dustin. Okay, now you guys remember this. We're increasing by 2 every time, right? Remember that that is your slope. Okay, so 2 is your slope. And your slope is always going to multiply by your x. Okay, so we have to have 2x. Okay, so not 1x. I don't know, Dustin, why did you think 1x? So maybe type that out as I'm talking, but yeah, I'd be curious as to know what you were thinking with the 1x. Oh, he's not? Oh, he needs to get back in. Okay. Let's see. Ah, he's now back. Okay. Okay, well then let's go on. So we've got the 2x represents our slope. And, oops. And so now we have to figure out what do we need to add or subtract from this to actually get our y value. So try it with the 1. So plug in the 1 in for x. So we would have 2 times 1. Well, that only gives us 2. So what do we need to do to 2 to get 1, which is our y value? I don't think anyone quite has this. Lita's working on it. Ah, subtract 1. Very good. So we would have to subtract 1. Good. So let's try it with the 2. So if we take 2 and then we plug in our 2, so our slope is 2, we said, and we subtract 1, we should get 3, and that's what we do get. Okay? So it looks like we're good. That is then our equation. So let's write out our final expression, our final rule. So our final rule actually is 2x minus 1, and that will give us our y values. So one thing to keep in mind, guys, as you're doing it, your slope is always going to be the number in front of your x. Okay? All right, let's do one more. Almost. I think this is our last slide, and then we are done. So I just wanted to review with you guys some, actually, let me make sure. Yeah, that's our last slide, and then we're done. We'll wrap it up. So I just want to make sure that you guys understand how to solve single variable equations. So I just wanted to run through a few of these with you guys and then have you try a couple. So let's actually try this first one together. Okay, so remember that when you're solving, you want to combine like terms. So what you want to do is put the x's on the same side. And it doesn't matter which side you put them on, but I tend to always move them to the left and keep my numbers on the right. So if I'm going to move this over, I'm going to subtract 4x from both sides. Okay. And then I'm going to write what I have now. So I have 8x left on this side. My 4x and my negative 4x cancel out, and then I'm left with minus 2. Okay. So I need to get rid of the 8. So what I need to do now is 8 is being multiplied. And so when you think of how to solve, you do the opposite of PEMDAS. So the opposite of multiplication then is division. So we need to divide both sides by 8. Okay, so now our 8's cancel, and we're left with x equals, now we always want to reduce. Okay, so we have the negative here. 2 goes into 8 4 times and goes into itself once. So our final answer, x equals negative 1/4. Okay, and you guys are going to have some problems like that in your homework where they end up as fractions. Okay. Lita, did you say Oh, you were saying 0.25? Very good. You could also write it as negative 0.25 if you want. Excellent. Good job. All right. Let's try this one then. So if we subtract x from both sides, we end up with x minus 3. And notice how I'm just rewriting the whole thing so I don't leave anything out. Okay. Now what I'm going to do is I'm going to add 3 to both sides. So some of you guys probably already are ahead of me and know what this equals. So x equals 8. Okay. So it's just a process of getting everything away from the x, but do it in the opposite order of PEMDAS. So do all your addition, subtraction first, get those away, and then get your multiplication, division away. Okay. So we'll try this one, and then I'll have you guys try one on your own. So on this one, all our x's are together, so all we need to do is get rid of the 1. So I'm moving it to the other side. I'm going to leave my x's over here. Okay, and I'm left with 8 on this side and 3x on this side. Okay, and this isn't going to be very pretty, but that's okay. So now to get rid of the multiplication, I'm dividing. Then my 3's cancel, and I'm left with 8 over 3 equals x. Okay, and I don't really want to leave it like that because that's an improper fraction. So if you want to simplify this, that would be better to a mixed number. So 3 goes into 8 2 times with 2 left over. So 2/3 is our remainder. Okay, and that is a better answer than 8 over 3. All right, why don't you guys try number 6? That should be pretty quick. See what answer you get. And again, if you guys want to go ahead and type those into your notepads, that's fine. Otherwise, and you know what, actually, Dustin, I probably need to make you a presenter again if you wanted to use your notepad. Okay, so Dustin, I made you a presenter since you came back in. So if you want to use your notepad, you're more than welcome to, or if you just want to do a chat, that's fine too. Okay, you guys, what does x equal in number 6? That's what you're trying to figure out. Ah, so Lita, very good, very good. All right, so Lita has gotten a 3. Dustin and Donnell, what do you guys think? Are you guys still with me? I'm not sure. All right, well, hopefully they are. So let's just go ahead and do this one, Lita, since you got it right. 5 plus 2 is 7x equals 21. And you divided both sides by 7 to get rid of the 7 next to the x. And you get 3. Good job. All right. So everyone's probably getting tired, so we'll do the last two together. Let's subtract 18 from both sides. Remember, we're getting rid of all the addition subtraction first. We're left with 6 here and 10x on this side. So this is going to be one of those not so pretty ones. We need to divide both sides by 10. And we end up with x equals 6 over 10. But remember, that's not a great answer because it's not completely reduced. So let's reduce it. And it looks like 2 goes into both of those. 2 goes into 6 3 times, and 2 goes into 10 5 times. Okay? All right, same thing over and over. It's just really important though that you have the discipline to always, write out each number, write out each step, okay? That way you won't forget any numbers, especially as our equations get bigger. So on our last one, we are going to add 4 to both sides. And let's see, what's 11 minus 4? Is that 7? Negative 7. Okay. Sorry, Donnell, if you put your headphones back on, it usually helps with the echoing a little bit. Thanks, Lita. Yes, very good. 7. All right, so this is one, you guys. This is going to be a nice one. Okay, so then to get rid of that 7, again, we divide both sides by 7. Okay, so a negative 7 divided by a positive 7 is just going to be negative 1. And x equals negative 1. All right, you guys. So I just want to make sure before we wrap up that there are no questions. Okay, so if you guys have questions, feel free to type them in the chat box or in your notes. That would be fine. One thing I do want to bring up too before we go to our final wrap-up slide is that when you go into week 3 this week, you'll have to hit everything in order to open the next page. So make sure you go to your materials, don't just click on your assignment, and then open everything in order. And you can keep hitting the next if you want. And some of the stuff in it will tell you on that page whether you have to view it, or whether you have to submit it, or whether you have to post a discussion. Okay, but just make sure you go through it all, and that will really help you guys anyway, because then that way you won't miss any instruction, you won't miss any lesson, and the problems will be a lot easier for you to do. Okay. All right, you guys. So now at the end of this, wrapping up, you should be comfortable now simplifying expressions. Okay, and again, practice on your own if you need to. Go back and do those 2 problems, compare, see that you get the same things. Okay, you should be very comfortable creating expressions from patterns as we continue on with that. And, at this point you will be somewhat comfortable solving single variable equations. But again, we're just starting that, and we'll continue that next week as well. All right, everybody, thank you very much. And if there's no questions, then I will see you all next week, same time, same place. All right. Okay. Thanks, everybody.